everyone. Let's solve this motion in one dimension problem. An inquisitive physics student and mountain climber climbs a 50-meter cliff that overhangs a calm pool of water. He throws two stones vertically downward, 1.0 seconds apart, and observes that they cause a single splash. The first stone has an initial speed of 2.0 meters per second. So the first task, okay, is for us to calculate how long after release of the stone do the two stones hit the water. That's the first question. Now the second question is, what was the initial speed of the stone, of the second stone? Then also we have, what is the speed of each stone at the instant they hit the water? So in this case, because the direction is downward, so it means that the value of acceleration, the value of vertical position, because in this case, the height of the cliff to the ground is 50 meters. So which means the value of the vertical position will be negative, okay? But to be able to calculate how long after release of the stone do the two stones hit the water, okay, I won't take the value of A to be negative and that of vertical position, which is the final vertical position, to be negative. Let's see how that works out. All right, the first question is for us to calculate how long after release. So we can say let T equals to time it takes, okay, after release of the stone, okay, how long it takes, that is time it takes after release of the stone, okay, the stones to hit the water, So now let's designate final vertical position. This is final vertical position. Final vertical position. Okay, let's designate that with Y subscript F. So in this case, we have final vertical position to be 50.0 meters. But it is important for us to note that the initial vertical position, okay, the initial vertical position will be equals to 0. Okay, so now acceleration is equals to free fall acceleration because the motion is downward. So I will take that to be 9.81 meters per second square. Okay, now we have that the first stone has an initial speed of 2 meters per second. So for the first stone V1 high, okay, has an initial speed of 2.0 meters per second. So we want to calculate the time it takes after release of the stones to hit the water. So we can then, apply one of the equations of kinematics. Okay, now applying the equations of kinematics, which is, let's make use of, since it is vertical position, so we have final vertical position minus initial vertical position, then the initial vertical velocity of the first stone, then plus 1/2 of AT squared. So let's substitute the values. This will be 50. 50 minus 0. Okay, this is 2 because we have it here to be 2. Then multiply by T. Then half of 9.81 multiplied by T squared. All right, so this will be, when we divide 9.81 by 2, that will be 4.905. This is 50 minus 0, that will be 50. So we have 50 equals to, this will be 4.905 T squared, then plus 2T. Now let me rearrange the equation so that we can have a quadratic equation. So we have 4.905 T squared plus 2T minus 50 equals to 0. So now we have a quadratic equation. So this is the standard form, for a quadratic equation. So we then have A to be 4.905, B is 2, and then C is minus 50. So which means T will be minus B plus or minus square root of B squared minus 4AC all over 2A. So we are using quadratic formula so that T will be equals to minus 2 plus or minus square root of 2 squared minus 4 times 4.905, okay, multiply by minus 50 all over 2 multiplied by 4.905. So that this will be minus 2 plus or minus square root of, this is 4. 50 times 4, that's 200. But minus times minus, that will be plus. So we have 200 times 4.905. So that will be 981, because 100 times, that's 2 times 4.905. That will be 9.81. Then multiply by 100. That will be 981. So we then divide it by, this also will be 9.81. So that t will be equals to negative 2 plus or minus square root of 985 divided by 9.81. Now, the value of t can only be positive. Okay, the value of t cannot be negative. So let's get the square root of 985. Okay, square root of 985. That is 31.38. So t equals to negative 2 plus or minus 31.38 divided by 9.81. So t will be minus 2 plus 31.38 divided by 9.81. Then this will be 29.38 divided by 9.81. So 29.38 divided by 9.81. Okay, that will be 2.99. Okay, so this will be 2.99 seconds. So t will be approximately 3.0 seconds. So this is the time after release of the stone. Okay, after release of the stones to eat the water. That's the time. That is, now, the question is that, okay, that's for the stone. All right. So then the second question, what was the initial speed of the second stone? So that means to calculate the initial speed of the second stone, we're only given the initial speed of the first stone. So initial speed, we can say let V2I equals to initial speed of the second stone. Okay, so to be able to calculate the initial speed of the second stone, okay, now we have here that it throws 2 stones vertically downward 1.0 seconds apart. Okay, so they are 1.0 seconds apart. So which means for second stone, time of travel, that will be for the second stone time of travel for the second stone will be 3 minus 1, and that will be 2.0 seconds. That's the time of travel. Okay, so to be able to calculate the initial speed of the second stone, it means that we again apply one of the equations of kinematics. Okay, we still use the same equation. So in this case, because the direction is downward, the value of final vertical position will be negative. So we then use applying y subscript f minus this equals to V2I times t plus 1/2 of at squared, okay, which is our t2. Okay, so this is negative. So in this case, this will be minus 50.0 meters. Yeah, because the direction is downward. So in this case, we can then have, so this will be minus 50 minus 0 equals to, so we have V2I multiplied by 2, because we calculated the time to be 2. Okay, 1 seconds apart, the 2 stones, thrown vertically downward are 1 seconds apart, and we subtract 1 from 3 to get 2 seconds. Okay, so that's 5 minus 50.0. Okay, then times 2. Then also the acceleration will be negative. Okay, in this case, a will be minus g. So we have 1/2 of 9.81. Then t squared, that will be times 2 raised to the power of 2. Times 2 raised to the power of 2. So this will be minus 50 equals to V2I multiplied by 2, then minus 4.905 0.05 times 4. So I'm going to move this down here so that V2I multiplied by 2 can be equals to -50 plus. So 4.905 times 4, that's multiplied by 4. That will be 19.62. Okay. So when we subtract 50 from 19.62, so this will be 2V2I will be equals to -30.38. So if you divide both sides by 2, okay? So we have the initial speed of the second stone to be equals to -15.19 meters per second. So this is the initial speed of the second stone. Initial speed of the second stone. Okay. Now, that's the initial speed of the second stone. We can approximate that to be -15.2 meters per second. Now, the value is negative because of the direction is the what? The direction is downward, and that's why the value is negative. All right, so what is the speed of each stone at the instant they hit the water? Okay, so that's C. Now, speed of each stone, just like final speed of each stone. So to calculate the speed of each stone, so we have the final speed. So for the first stone, we have that the first stone has a final speed of, now, final speed equals to the initial speed of the first stone plus AT, T1. T1 is given to be, we calculated that to be 3 seconds. That's for the first stone, that's 3 seconds. Okay, that's 3 seconds. So the value of A in this case will be negative. Then also the value of V1I, initial speed of the first stone, will be -2.0. So that this will be the final speed of the first stone will be -2. Okay, then minus, because the acceleration will be negative, 9.81 multiplied by 3. Yeah, so 9.81 multiplied by 3. So this will be -2 minus 29.43, and that will be -31.43 meters per second. So this is the speed of the first stone. Remember, we want to calculate the speed of each, okay, at the instant they hit the water. So this is for the first stone. Now, for the second stone, that will be V2F, okay, which will be the initial speed of the second stone, okay, minus, this is also negative. This will also be negative. Then minus A times T2. Let's not forget that T2 is what? T2 is 2 seconds. So this will be, the initial speed is what we calculated here to be -15.19, then minus 9.81 multiplied by 2. So that's it. So when we multiply 9.81 by 2, okay, that will be 19.62. So this is -15.19 minus 19.62. And we have the speed of the second stone at the instant it hits the water. Okay, the stone hits the water will be -34.81 meters per second. Now let's not forget that the value of each speed, okay, the value of each is negative because the direction is downward. Okay, so because the direction is downward, okay, if the direction is downward, then it means that acceleration, okay, will be negative, and the final vertical position will be negative, while the initial vertical position will be 0. The noblest pleasure is the joy of understanding. Bye bye.